Hello, this is Dan Alford. Welcome to the ARC Specialties Weld of the Week.
Today we're going to talk about bleeders. One thing that ARC Specialties is well known for is hot wire gas tungsten arc cladding systems. These machines are used to apply Inconel or chromium nickel alloys to the inside of oil field parts. The purpose of this cladding is to avoid problems with H2S or sour gas, which can cause catastrophic failures. After welding, these clad parts are inspected using liquid penetrant inspection. You spray a penetrant on the part and capillary attraction draws the penetrant into any surface defects. Then you spray a developer on top of that and the penetrant comes back out and is visible as red spots, which are called bleeders. Most inspectors incorrectly interpret these bleeders as porosity, but I've always thought they're probably oxide inclusions. With the help of Dr. Lose at the Rice Institute, he used scanning electron microscopy and energy dispersive X-ray analysis to prove that all of the defects that we've found in the field were indeed nothing but oxide inclusions. Based on our work with Dr. Lose, we decided to further investigate this phenomenon of oxide inclusion defects. Liquid penetrant inspection has a lower detection limit. Below this detection limit, there's still oxides present in the weld. What we needed was some way to measure the amount of oxides present in the weld. Were we right at the brink of having a defective weld, or did we have a very clean weld? We had no way of differentiating the two. So to conduct this test, what we did was we started adding oxygen to our shielding gas. First we used ultra-high purity argon, then we went to 50, 100, 500, and 1,000 parts per million oxygen. And what we did is we cross-sectioned these parts, and using microscopy and intelligent machine vision, we actually were able to measure the ratio of oxide inclusions to total weld area. What we found was if you had greater than 0.0008 or 800 parts per million inclusions, then you could detect these defects with liquid penetrant inspection. But you could also determine if you were very nearly at that limit or if you had an extremely clean weld. Our inclusion ratio test is a powerful tool. Not only can you use it to determine best practices, you can also quantify base metal cleanliness, shielding gas purity, and wire quality. One of the biggest variables in Inconel overlay cladding is wire quality. We've seen a huge range of results in our inclusion ratio test looking at different brands of wire. Our inclusion ratio test has shown a wide variation in wire performance from brand to brand and even lot to lot. We've seen inclusion ratios range from nearly 0 to above our 0.0008 limit just by changing wire. We suspect most of this variation is due to surface cleanliness and wire cleaning techniques. Unfortunately, industry never really embraced our inclusion ratio test due to the cost involved, but probably we should have. My opinion was reinforced this week when Dave Hebel went into our laboratory to produce a weld procedure qualification test. In this case, he wanted to do 3/4 inch thick welds because we're qualifying the weld material as a strength weld rather than simply an overlay. Every 2 layers, Dave had to mechanically remove the oxides from each pass. On the last 2/3 of the final pass, he ran out of wire. He switched to a different brand of wire, and you can see from the photograph there's a noticeable improvement in surface quality. You can tell a lot from the weld just by looking at it. We didn't run an inclusion ratio test, but rest assured the original wire had a much higher oxide level. You can see it on the surface. In the Inconel cladding industry, weld quality is extremely important. This is why I like to stack the deck in my favor. I strive to remain agnostic when it comes to weld filler material manufacturers, but I must say lately the Bowler wires have been performing extremely well. The point of my blog today is when you're faced with welding defects, I want you to consider everything. It could be base metal, shielding gas, welding technique, welding program, you name it. You need to question everything when you're trying to solve a weld defect problem.
We look forward to posting new episodes of the ARC Specialties Weld of the Week. If you're one of the thousands of operators of ARC Specialties equipment around the world and you have a weld that you would like to showcase, please contact us. At ARC Specialties, we thrive on problems. Send us yours.